Check, check. You all are able to hear me, right? I'm able to hear, yes. First of all, I will have to thank you even before you start listening to me because you all are sort of waging the toughest war on earth. What I mean to say is, at least to me, the toughest war to wage is with that good weekend afternoon sleep after that sumptuous lunch, isn't it? I mean, we are all Bangaloreans, techies mostly here, right? I mean, I've had a difficult week, to be very honest. So being here and hearing all these amazing talks is what has actually kept me going. Because when I initially knew my session was in the second half, I kept asking my people to please, can you prepone it, prepone it. I'm sure people won't be able to listen. So I'm so glad that you all are here, and I could see the faces now that I'm here. You all are attentive, so thank you very much. And I think the previous speaker was amazing, Anubhav, right? So he set a beautiful stage for LLMs. So I think you all now know to define what is a large language model, right? And you sort of know what it does. Yes? Can I, people who say yes, can I see you? Good, right. Okay, so now about a little about myself. So I am Vaishali, and I come with about 9+ years of experience. I work at a company called Indium Software, and I lead a team of about 25. I'm leading about 5 projects in parallel in different domains: healthcare, retail, finance, and manufacturing. I also hold a professional postgraduate in AI and ML. And I am a tech evangelist. I love spreading knowledge, so I also work as a corporate trainer as and when I get time. So yes, I'm pretty busy. So when I put it like that, I feel I'm busy. Yes, right. Good. So that's about me. So a quick overview on the agenda. So mine is going to be definitely a lighter session. I mean, there's a lot of intersection with mine and Anubhav's, but you will see different thoughts as well flowing through. So first, again, always, I think every talk today is beginning with this. I hope you all don't get bored with it. Introduction to LLMs, and then we'll discuss about what is an advisory bot, and then we'll discuss about how LLMs can be used in advisory bots or why they should be, okay? And we'll also be discussing about just an overview, a process flow on how advisory bots can be developed using LLMs. I'll summarize whatever I said quickly, and then we'll go on for a Q&A session. Right. So what is an LLM? I think you all know. You just showed me your hands. So I'll just reiterate a couple of points that you already know, that you've been learning since morning. So a large language model is a type of an AI model designed to understand and generate human-like language. So I think with the amazing demos that were shown by the previous speakers, you all can definitely agree to the point that yes, LLMs generate human-like language, and it's very nice to interact with an LLM, right? So that's why I saw a lot of different interactions have happened by the crowd here. Good. So these models, first of all, how are they able to interact this well? See, it's not like language models are new to the arena, right? Is it? Is it so? Is generating language using a language model very new? Yes or no? No. No is the right answer, right? Because this field was already being explored. If you sort of look at the AI landscape, this is an already explored field. But what has made large language models stand out is its ability to amazingly generate human-like language. It is so much human-like that you couldn't even anymore differentiate between whether you're talking to a human or to a language model. That is to a computer system. So how did it do that? How was it made possible? It's made possible because it has been trained on a vast amount of training data, and not only that, it is also a very, very large model, right? So when you look at GPT, people are following, I know it's Google developer groups, but that's one of the things that I could come up with quickly because I've been working closely with that of late. So the GPT-4, when you look at the parameters, anybody who can guess how many number of parameters are there without looking to your phone, without Googling? How many number of parameters has it been trained on? 70 billion, right? Okay, that's one answer. Any other answers? Over a trillion. Yes. Now, any other answers? 120 billion. Right. Yeah. 130 billion. Okay. It's become like an auction now. 70. One, twice. Right. So the person there, so his answer was right. It's almost 1.72 trillion parameters now. These models are becoming crazily huge, and they are being trained over weeks and weeks before they are brought into our hands, if you don't know. Right, so that's the main reason why these models are able to generate such human-like content. So one is because of their mere size, and second is because of the sheer training data volume. Okay, so literally it is, you can imagine like you just run a crawl over the entire internet, and then you get the data, you train the LLM with all that data. So that's the amount of data it's being trained with. Right, so LLMs, talking about their capability, they are able to understand context, generate coherent text, and they are able to perform various language-related tasks, such as translation, summarization, and question answering. So I think for some of these you've already seen demos as well, so I'm sure you all can agree to what it can do. So what is an advisory bot? Now, before I move to the next slide, any idea? Anyone here guessing? What is this topic? Yes.
For example, if you have an LLM that has been fine-tuned on a data, for example, financial data of say various stocks of like 20, 30 years. So if I ask that bot, what stocks should I purchase now that will benefit me to make my portfolio? So that is what a financial advisor bot would be.
That's right. Absolutely right. Yes. So he summarized my entire talk in just a few seconds. Right? So yes, that is what an advisory bot is. So an advisory bot is a computer program which is designed to simulate conversations with users, especially in natural language, to provide information, assistance, and guidance. So you can use an advisory bot to get information about whatever things that you want to, and I mean, basically on the data that you've trained it to work on. And you can also get assistance as to what should I mean, like, okay, I'm looking for this. So do you have it? The bot will assist you. And the bot can also guide you. Say you're stuck in a situation and you do not know where to move next. Like we had a therapist friend here, right? So you're stuck there and don't know where to move next. Yes, you can use an advisory bot to do that. So these bots, they leverage artificial intelligence and machine learning algorithms to understand user input, and they generate relevant, context-aware responses. See, that's the major catch there, because, see, say I have been conversing with this bot, okay, and I said, hey, hi, I want to go to Japan. So, and what's the flight, I mean, how much would the flight ticket cost? Okay, so the bot will give you a flight ticket and then say, plan me an itinerary. So what if, see, only if the bot is aware that you have been planning to go to Japan, which is available in the previous input that you gave to the bot. Only then it will be able to give you a tour itinerary for Japan. Else it will just give you some tour itinerary which will not be useful, right? So that is what is called as context awareness. It's very, very important when you're building a bot, especially when you're building a production bot, which is actually going to be used by a lot of users, right? So I think many of you here must have already experimented with all these open source available bots. We just saw the percentage. Indians, we stand at 73% usage, right? So you all have used it, isn't it? So when you were talking to the bot, right? So one after the other, did you ever had to reiterate what you said before? Especially the important stuffs like the nouns, the places, or the objects. No, right? Did anybody do it? Yes or no? No. Can I hear that? No. Right. So why didn't you do it? Now, because all these LLM models are built to be context aware as well. They can remember. So how can you be context aware? How are we context aware? How are we context aware? What is context awareness with respect to us? See, you all know that all the AI solutions are inspired from humans, right? Yeah, you know that, right? So what is context awareness? How does it translate it to what? to us. So what is meant by context awareness now, for example? See now, okay, if my question is not clear. So now we are in the advisory bot slide, okay? Now you all remember the flow of my slides, isn't it? We came from introduction, I introduced myself, and then agenda, and then LLM. Now we are in advisory bots, right? Now what if we all were like Gajini? Yeah. So I stand here, I say I'm Vaishali, and now I have people here wondering, hey, who is she? Right? What if it happens like that? Then that means you're not context aware, which now means, I hope you all can sort of relate context awareness to us. So what is it? It's memory, right? It's memory. The bot has to remember what was asked to it before so that it can relevantly continue to answer all the questions asked in connection with it, right? So advisory bots do have to generate relevant context-aware responses, and these bots can assist users in making informed decisions. Particularly, these bots are valuable in situations where complex choices are to be made, because complex choices always require comprehensive information. I think any choice for that matter requires information, but when it's an even more complex choice, you need more information. So that is where advisory bots are very, very useful. Okay, so the moment I said advisory bots are supposed to be, or are designed to simulate conversation with users, how many of you thought that, what is new here? Isn't it just a chatbot? How many of you thought that? Yeah. See, I have all these people, that's right. So, I mean, I think these people who raised hands are the ones who already know the AI landscape about chatbots. For others, chatbots were the preliminary AI solutions that we had. In fact, 2016 was declared as the year of chatbots, wherein we had all these AI solutions that were built to converse. So most of the bots that you see popping up on the right, on the bottom right of the screen in your bank websites or on your insurance websites, all those applications are chatbots. Okay, so you'll click on it, you'll see a bunch of buttons there, you'll click on that button and then it'll take you further and further and further, isn't it? I hope you have used it. So those are called chatbots, okay? So now let's look at how different is an advisory bot from a chatbot. So this is a scenario, a simple scenario. Say you want to know the sales of a particular product in a particular region and in a particular year, okay? That is, as given in the example here, like you can see, it says, show me the total sales of UK in 2019. Yeah? Now say this is the scenario, okay? Now we'll first see how you'll have to interact with the chatbot, if at all you had to. So if you talk to a chatbot, say, show me total sales, now your chatbot will ask, okay, of which region do you want, right? Oh, that's obvious. So it'll prompt you for more and more information, because that is when your chatbot can understand your intention, right? So it'll ask, okay, so which period are you interested and for which country are you looking for? And then we'll have to say I'm looking for UK, say in 2019. Okay, until then it's fine. So after that, if you ask, show me last quarter's sales, your chatbot will ask, okay, which quarter do you want? Or say, show me the quarter sales, or split and show me the entire year by quarter sales. Now your chatbot will sort of stop, because it will ask you further and further questions, first of all. If you ask it to split by quarter and answer, only if the details are there, and then only if it's able to retrieve all those details, it will respond. Now, if you sort of zero it down and say, okay, see, I want last sales quarters of UK of the year 2019. If you give this as a proper input, then your chatbot will give you some output numbers there, okay? Now say you want to generate you want your chatbot to tell you, can you show me sales split by country? Okay, by country. And by this time, your chatbot will sort of break down. The reason being, sales split by country is not something which will be available directly in the data that you provide. Agreed? Unless and until you give a very structured data, this data is not going to be there. Like as it is, it's not going to be given on a silver platter to your chatbot. So this is where your chatbot will break. Now let's have the same conversation with an advisory bot. Okay, so show me sales in the UK in 2019. Yes, the numbers will be given. And then say you ask the same question, can you split that by product? Now look at the advisory bot's response. You'll get a response which will also be a graph, a beautiful graph there. So these are the advantages of an advisory bot. So the advantages of an advisory bot over a chatbot is that it will be even more context aware, and advisory bots will be able to generate dynamic, I mean, advisory bots would be able to dynamically generate interactive outputs, which will be very, very understandable for any user. Okay, so this is about an advisory bot, and an advisory bot is not a chatbot. Okay, so now that we have established the difference, let's move ahead to learn about why should an LLM be used in an advisory bot. Yeah. So now that we have already, I think since morning we've been talking a lot about LLMs. I've also given you a background. I've given you a background on what an advisory bot should do. So can I expect answers from you to sort of tell me why an LLM should be used in an advisory bot? I'm beginning to see people sort of sleep, so it's important I ask questions. Yes.
Because LLM is already trained on vast amount of internet data, so it is already having the context awareness.
Okay.
But on top of that, if we fine tune that model, or if we try to do even instruction fine tuning or with PEFT, we can direct it to generate a particular domain expertise, which can be either finance or medicine or another sectors.
Yes, so it's been trained on vast amount of data, because of which actually the answer there is, I mean, one of the answers there is, it can generate a human-like content, and it can understand, first of all, your input very, very clearly. Okay, so if the data is there, it'll say it's there. If data is not there, it'll say it's not there. Okay, so that is one reason why LLM should be used. And thank you for your answer. I think you also gave some more technical terms there. So we'll discuss that later. So coming to the other reason, so let's get into the slide now. So the first thing is because LLMs can understand and generate human-like content. It can understand anything that you give it to at the input. Okay, so that's amazing. And second reason is because LLMs can help you personalize the interactions by keeping a record of the user preferences, history, and specific requirements. Now this is simply because your bot is big, it's huge, right? And like he already mentioned, it's been pre-trained with extensive amount of data, which can sort of handle any queries that comes the LLM way. And LLMs are versatile, and they can be adapted for various industries. So the example I cited there was already given by one of the participants. So in finance, an advisory bot powered by LLMs can offer personalized investment advice based on user profiles. Now this personalization is what I love in LLMs. Now, personalization is really important. It's there because an AI model, when you give inputs to it, it'll be able to understand who you are eventually. Okay, I'm addressing a largely Indian crowd here. So, how many of you love shopping on Myntra rather than Amazon? How many of you like that? Yeah, see, I expected more, but probably you are raising hands like this, but I'm sure a lot of people here who have used Myntra, you must at least do window shopping on Myntra, because sometimes prices are high on Myntra, if you know. And then you'll buy it on other websites, right? So coming back, why is it that you like shopping on Myntra? Quality of what? The cloth? You'll never be able to measure that, right? Only after it comes home you'll know it's a different product. What is that quality that you really like? UI. Somebody said UI? Okay. What else? I heard personalization. Who said that? Personalized suggestions. See, that's the main reason why people love Myntra, right? So, off late, if you've been an avid user of Myntra, you go select a top or a pant from a brand that you have never bought before. Myntra will tell you, hey, see, I think size L will fit you. I think size XL will fit you, right? Yeah, so now I see the nod. That's what I mean by personalization, okay? So Myntra keeps track of all your transactions, And because of that, Myntra is able to tell you. And you know what Myntra would also ask? If you are buying this for example, Vaishali, this will be the size. If you are buying it for Ram, this will be the size. Have you seen that? So when you purchase a when you purchase a product, Myntra would ask, whom are you buying it for? Right? So basically, you're labeling data there. You're labeling data there, you're training Myntra's AI recommendation system model at the back end. Right, so that's what is meant by personalized recommendations. So personalized investment advices can be given by an advisory bot that you create using LLMs. That's because LLMs can, again, I'm iterating this point, LLMs can handle a large amount of data, and LLMs are literally huge. So they are very context aware, and they'll be able to give you excellent advisory bots. So having discussed this, I think there were some points given by all of you already, right? So finance is one domain, healthcare is another domain. So here are a few examples as to how it can be used. So in healthcare, if you see, an LLM-powered advisory bot can understand patient symptoms, medical histories, and it can offer personalized health advice. It would be good, right? Now, there are several branches here. You can even build a nutrition advisory bot, right? And it'll be very good. How many of you are trying to gain weight or lose here? I don't want show of hands, that's your personal choice, but yes, I think most of us are trying to improvise our health and everything, right? Imagine having an assistant in your hand, a reliable one, which has been trained on lots of information, which gives you various options. It'll be good, right? So that's in healthcare. Moving on to finance, I think it was already said. So it'll be able to give you personalized financial investment advices, and it'll also help you gather information as well. So apart from advising, that's what I said, apart from guiding you to what to do next, it will also be able to assist you with any information that you want as well. Moving on to e-com recommendation, I think we already discussed this. So based on customer preferences, purchase behavior, and transactions as well, it will be able to provide product recommendations. An LLM can be used here, an advisory bot can be used. So imagine you have an assistant popping up on Myntra and always keeping you engaged while you're shopping, saying, hey Vaishali, hi, you're here. So are you here looking for a t-shirt or a top? I think it's your birthday around the corner, so what would you want to buy? I see that off late you've been buying all black clothes. Why don't you go try something colorful? Would it be nice? Would you like it? I think we're all getting to spend more time only with our phones these days, so I think we'll definitely love that sort of a bot helping us out there, right? So moving on to human resources, see, that's another a very potential use case which can be quickly implemented in all of your companies, in fact, right? So in HR, an advisory bot can utilize LLMs to assist employees with queries related to company policies, benefits, and career development. Tell me something, how many of you here clearly know about your company policies? I guessed so. It's not possible, right? Now, how many of you have always been able to reach out to your HR on time whenever you wanted help? Yeah, that's again, okay, people who are able to, you're lucky enough, your HR are responsive, great. I mean, HR also have a lot of tasks, right? But typically you will reach out to them only in case of severe emergencies. But what if you wanted to know about how many leaves can I avail in a year? What if you missed the induction class? What are you going to do then? So you can't keep pinging a HR always, right? So imagine having a bot in your organization, wherein it's accessible to all your employees and employees have information to it. So it'll be amazing, right? So this is a very, very potential use case. I think people who want to explore, you should definitely explore this arena because this is easy to start with, let me tell you. Amongst all the use cases I've presented here, this arena is very, very easy. Right. So now that we know about what's an LLM, what's an advisory bot, how different is it from a chatbot, and that we have seen some use cases around this, now let's just look at a process flow on how advisory bots can be built using LLMs. Okay. Right, so I'm not going to have code and all. It's just a simple process flow because I realize that if I do coding, then it'll have to be a very, very long session. So here it goes. So first thing that you do is, I think in one of the previous speakers said, or one of you said, an LLM is a base model, right? It's the training, the vast amount of training data it has been trained with. Now that process is called pre-training. Okay, that process is called pre-training. So it's pre-trained and it's available for you. Can you just use that LLM model directly on your application? say for instance, to know about your company policies, would it know? No, right? So which means you'll have to align this base model to your use case. All right? So how do you do it? Now you first collect all the necessary data that is required for your particular use case, and then you align, sort of fine-tune this LLM model on your data set. Now, people always think, since we are very adept with training machine learning models and be it deep learning models as well, when I say fine-tuning or training this LLM, always people say, okay, I'll have to train my LLM, right? That's what you're saying. That's something that they keep asking me. What does fine-tuning mean? What literally happens here? See, that's where LLM makes our life really, really easy. All that you have to do is follow the data ingestion pipeline that I've given there. So what you see, as a first step, you first collect all the textual documents, and then it gets broken down into small, small chunks. It gets embedded, as in an embedding vector is created for each of the input textual data. And once these vectors are created, they get stored in the vector database, and that's it. That's it. That's what you'll have to do. Now what you have to do is you have to connect your LLM model, basically make this vector database accessible to your LLM model, and the model is ready to go. So this is something that you all have to clearly understand when it comes to fine-tuning an LLM. Okay, this is all that you have to do. This is something that, I mean, if you people go walk out of this room with this understanding, I'll be very, very happy today. I would consider my talk a success, right? Because whenever I meet a lot of people, I have a hard time explaining them about what is training an LLM, how different is training an LLM from training another deep learning model, where you literally have to run it through all that data, right? Okay, so now coming here, what is chunking? Anybody wondering why should the data be split into chunks? Anybody wondering about that point? What is meant by chunking? Yeah, I see. Right. So you see your input data that whenever you choose an LLM, it should be a problem statement where you really want a generative AI solution, right? And every LLM comes with something called as a context window, a context size. Yes, I hope you have seen it. I hope people who are following the news, you might have also seen that this context window size has been continuously improved ever since the first LLM model was introduced, right? So when you're dealing with LLM, for example, when you're dealing with LLMs for an advisory bot, right, the size of the input documents that you send to the LLM would be really huge. Agreed? So say it's your company policy document. It'll be at least 20, 30 pages, right? 100 maybe, if it's a huge company. So 20, 30 pages will be there. Now you cannot just create a huge embedding vector for all these 20, 30 pages together. It wouldn't make sense, right? So what we do is we break down this data, this huge data, into manageable chunks. Okay? Now when it comes to manageable chunks, so once your data is broken down to manageable chunks, then you send it to the embedding model, and each chunk is getting embedded by the embedding model, and it is being created as a vector embedding a vector embedding is being created for each chunk, right? My mind is racing against thoughts now. The reason is I want to give you one more information here. When it comes to chunk size, right, typically, at least when I started, I always had this question. Okay, there's a chunk size. So what should be the size of my chunk? Yeah? Isn't that a very important question? What should be the size of my chunk? So the size of your chunk should be decided based on the use case that you're working with. Say you're working on an advisory bot use case, then your chunk size can be anywhere between 512 characters to 1024 characters. Yes, by the size of chunk, it means every character is measured. Okay, so you can have 512 characters, 1024 characters, or say you're not using this LLM to build something, as an advisory bot, but say you're running this on Twitter data. Okay. So it all depends on the input data that you're dealing with. Say you're running this LLM on Twitter data. Twitter data will be very small, right? All your tweets, how long would they be? Maximum of what, 250, 300 words? Yeah, 500 words maybe, at max. So when you're just dealing with Twitter sort of data, then you should not actually go with a larger chunk size. You should go with a smaller chunk size. So chunk sizes can be 128 or 256 characters in size. Understood now? I hope it makes sense, right? So that's how your chunk size is supposed to be selected. And then when you're creating chunks, there's also one important thing that you have to do. It is important that you also introduce something called as chunk overlap. Chunk overlap as in, you don't just cut off these characters then and there. See, these are all being broken down by characters, right? Now say my name is Vaishali, okay? My name, say I define my chunk size as 6. So my name will be one chunk, and then is, and then VAIS would be another chunk. Understand? This is how it will be, okay? Now if this is going to be separated in this sort, and if it's going to just be individual chunks, do you think the LLM will be able to make sense out of it? Would it know that VAIS and HALI, which is there in the third chunk, they are continuous? Will it know? No, right? That is where we have another parameter to be set here called chunk overlap. Okay? So the overlap helps to mitigate the possibility of separating a statement from important context related to it. So this chunk overlap is also again a measure of characters. So you can have an overlap of 70 or 100. You can experiment. These are like hyperparameters. Okay? You can really experiment with the performance of your model by checking the performance of your model. So moving next, I think about embedding, it was already discussed. So embedding model is used to vectorize your input text data. I think you all already agree. Some of you answered, right? Vectorizing data is really important because any machine learning model will not be able to understand text as it is, right? It will be only able to understand numbers. So that's why we have the embedding model there. So now you have the embedding vector store. Okay, I've got my cue. I'll try to speed up my talk. So then you have the embedding vector store there. And what happens is, so here, beyond this point is where it turns to be really interesting. So your embedding vectors are there. Now what happens is, the input question comes from the user, okay? So as soon as the input question comes, this input question also has to be embedded by the same embedding model. Then what happens is, the similarity between the input question and the existing chunks, the existing vectorized chunks of data is calculated, and the relevant chunks are picked. So chunk selection happens, the relevant set of chunks are picked, and then what happens is, the input question with the relevant set of chunks along with something called as prompt. You have been seeing a lot of prompts since morning, right? So prompt will also be there, and all this combined, the final prompt will go to the LLM, and then the LLM will generate response which comes back to the user. So this is the overall process flow of how you can use an LLM to create an advisory bot, or truly for that matter, any textual solution that you want to build. This would be the architecture. Okay, right, moving ahead. Challenges and considerations. While building all of this and using this looks really, really great, there are a lot of challenges when you're working with an LLM. Anubhav has already put up some of the points out there. So the first thing is development and usage cost. Development cost is when you are developing the solution, but there's something called usage cost as well. That is, every time you query your LLM that's there in production, you will be charged. Not only for your question size, but also for the prompt size that you give within, and for the answer it generates. So it's really, really a costly affair. You need to be sort of careful when you choose these models. The next is hallucination. Hallucination is when someone comes to you and talks like as if they know everything about what you are asking them, but they really don't know what they're saying. Okay, that is what hallucination is. LLMs can hallucinate, and how do we stop hallucination is by using RAG techniques, retrieval augmented generation. So just a minute here, if you see in my previous process flow, you see the term. So RAG is nothing but when it's retrieving data, you retrieve the data, and along with the user input question and the prompt, you send that data as well. So you tell your LLM, see, this is the data that you're supposed to look into and generate a response. So it will help to reduce hallucinations in the LLMs, okay? And then there's also something called chain of thought prompting. Now I'm just leaving some terms there so that enthusiasts, you can go and read more about it. Next is dynamic knowledge updates. It's very important that you keep updating your database, so please do that. Only then your LLMs can stay relevant. For example, the GPT 3.5 model was able to answer queries only until September 21, right? But now GPT-4 is able to answer until date. So it's very important that you dynamically update your database. And next is bias. I think this is common to every ML model that you create. So you need to be very, very careful with the input data. So you need to be careful about the quality of the input data to ensure that the model is not getting biased to any of the things that it's being trained with. And lastly, now this is interesting because, so you've created an advisory bot. Say, for example, you've created an HR advisory bot and it's there available for all your employees in your organization, okay? Now, how would your employees know what are the questions that they can ask this bot? What if somebody asks, where is the restroom? Can you guide me? See, that's not something that a bot is needed for, right? So it's really important that you put up what is necessary, or what if the person asks, hey, what do you think my salary is, or how much salary is given to this person? These are not questions that the employee should ask. So you need to craft a user-friendly interface that effectively communicates the capabilities and limitations of the advisory bot as well. All right, so I'll leave it there with these thoughts. And a call for action. I know that there has been a lot of promising numbers which has been shown since morning, but I just stumbled upon this survey, which was, I think it was done by Electronics Hub. Now this is a survey that depicts the number of Google searches on tools for building text-gen AI solutions per 100K of a country's population, okay? I thought India would be somewhere in the top of this list because at least everywhere I see people are talking about Gen AI, but I don't see India anywhere there. So let's develop the curiosity to know more about Gen AI. Let's build impactful solutions and top this list in 2024, all right? So that's it. That's about the talk here. So do we have any questions?
Thank you, Vaishali. I'm very sorry, but we are very out of time right now.
It's okay, no
and I don't want to end up. But she will be around here, so I'm pretty sure if anybody wants to talk to her, you can catch up with her here or in the community lounge. That's where I'm going to guide people out as well, because if anybody wants to attend the WTM catch-up, that's the Women Tech Makers catch-up, that's happening 3 to 4 p.m. in the community lounge. Thank you again. Once again, a round of applause for Vaishali Balaji, everyone. All right. Who wants to win some goodies? Show of hands. Rest of you don't get anything. Only those who showed hands stand up. Okay. So I just have a few questions until we get the next speaker set up and everything. I just have a few questions here just to see if you've been paying attention. Let's see. And if you get the correct answer, then I will give you something nice. Okay? T-shirts, yeah, they're nice, no? They're free. And the same size. Yes, you know it. Don't act smart. Don't act like ChatGPT. Don't hallucinate. See what I did there? Okay, just kidding. But here we have some questions. Let me see. Okay, how many of you attended Satish Vijay's talk in the morning? Okay. Now, hands down. And don't shout out the answer. If you shout out the answer, all the t-shirts go to me. Okay? So raise your hand and then I will pick. And mics, do we have mics ready? One more and one more. Okay, one in the back. And this time I'm going to try and look way back there. So I might actually do that. Let me see. I might come down. You guys have won something before. Let me see in the back also. No, people. Okay. Don't see the question. Cheater? Everyone, you know, over here. Okay. So what is the name of the tool that Satish has created? The website as well. Okay, the first hand I saw. There, the gentleman jumping up and down. Yes, there, him. Very excited. I know.
Gen CMD.
Gen CMD. What's your name, sir?
Raghu.
Raghu, congratulations. Good answer there. Gen CMD it is. Can we have excellent, lovely t-shirt for him? There, that's him there. Can we have some light music going as well, please? That'll make the session more fun. Okay, so in dev workflow, okay, the top thing that ChatGPT or any kind of Gen AI was used for is coding. Okay, what is the second and the third thing? Okay, I see this hand first. Wait. Okay, and I will give one person over there. Okay, the lady here. So first person over here. Here, sir. Here, right here. His hand went up straight away.
Debugging.
Debugging is correct. And the ma'am over there. Understanding. Okay, if I don't get a better answer, I'll probably give it to you. Maybe later. Next one there, right next to him. Okay.
Searching internet.
Searching, no. Third one. What is the third one? No. Okay. Somewhere there, please, in the center, there. Yeah, him, in the jacket, here. You. Yes, you.
Reading others' code.
No, okay, I see a hand going like this. Yes, you. Here, that person in the jacket again. There are so many jackets. I'm just saying jacket.
Summarization.
No. No. Okay, 2 hands up. Debugging was the second. He's already got something for that. Did you get your t-shirt already? No? Okay.
Code documentation.
Absolutely correct. What's your name here? What's your name?
Gautam.
Gautam and Ayush tag teaming there, debugging and documentation. Everybody was going all around, logging, understanding on the documentation. So much problem. I have to go and do that tonight. But yeah, so can we have some t-shirts for Ayush here and Gautam, right? Gautam is the way back here. Ayush is here. All right.